Good afternoon, everybody. Welcome to Hot Tuesday afternoon of Chem 170 with your host, me, Dr. White. How do I know it's Tuesday? Well, I can look at the bottom of my computer and it says Tuesday, but last night I put out my garbage in front of the house and Tuesday is garbage pickup. So now I know it's Tuesday. All right, couple things. Don't forget, lab due today. And later on today, we'll be doing an interesting lab. Also, I looked at the schedule and considering I'm going to lose a lot of time on July 4th, like just about a whole week almost, because we won't have class, it's a holiday, we're doing good. Now, keep up. Don't fall behind. Do the practice problems. Speaking about practice problems, I think I mentioned yesterday. If not, I'll do it now. Tomorrow, I'll go through the ether epoxide practice problems. You should be doing that. Now, not to scare you, but I will. Test number 1 always has the highest average for this class. It's about 82. I think about 65, 70% of the class earned A's or B's, which is pretty good for organic. And test number 2, and it's happened where what I'm about to tell you is wrong, but historically, that's usually the lowest average because there's a lot of stuff on there. Study, keep up, do the practice problems. Remember, on Monday and Wednesdays at 6 to 7 on Zoom, I have office hours. I'm there to help you. All right. I didn't mention it yesterday, but Dr. White loves aldehydes and ketones. Yep. How many of you are familiar with the term comfort food? You all heard that? That's when you're not feeling good and you want to make yourself feel better. You eat something that you really love. Comfort food. And my dangerous comfort food, one of them is the onion and sour cream Lay's potato chips. I only buy those a couple of times a year because they just evaporate like that in my house. I mean, even faster. I can snap my fingers. But when I'm not feeling good or want to feel better, I have, now you're going to know I'm an organic chemist, comfort functional groups. And 2 of my favorite are ketones and aldehydes, which we're going to talk about now. So if it looks like I'm having way too much fun, I am. And the first patent I had, and the last one, I used my knowledge of ketones and aldehydes to make things nobody else and do things nobody else did. Also, my PhD thesis dealt very heavily with ketones and aldehydes. All right. Yesterday, I introduced you to him, so say hello. Oh, that was hokey. But anyways, aldehyde, carbon, double bond to oxygen with a hydrogen and carbons, aldehyde. And I showed you different ways you can write it. Ketone, carbon, double bond to oxygen with 2 carbon groups, R and R prime. We used a prime, just like in math, you use X and Y to say they could be different, but they could also be the same. If you just put R and R, they'd always have to be the same, but they can be different. This is a ketone. I'm going to have some fun. Carbon, double bond to oxygen. This carbon in an aldehyde has a hydrogen and an R group, carbons and hydrogens. And for a ketone, it's not spelled with a Y, even though students like to do that. I don't take off for spelling. Ketone is a carbon, double bond to oxygen with 2 R groups, and they can be the same or different, which is why I have R and R prime. Aldehyde, ketone. Now, this chapter, I'm going to talk about how do you name them. I'll talk about where you find them in nature. We'll talk about some amazing ways of making them. And then we'll talk about, now the fun part, reactions of ketones and aldehydes. So let's get started. Oh, one thing I should mention, and this is very important, especially to me, Dr. White. Hold on one sec. Let me get this out of the way. The carbonyl group. Now, the carbonyl group is not a functional group, just like a methyl group is not a functional group. But the carbonyl group is a carbon double bond to oxygen. This is so important. You should be able to draw, excuse me, a carbonyl group and describe with words what a carbonyl group is. Oh, I got some frog in my throat, ribbit. But anyways, what is a carbonyl group? You should know how to describe it and draw it. And a carbonyl group is carbon double bond to oxygen. And you draw it just like I have here. I'll do it again. Carbon double bond to oxygen. It's got two other things because there's 4 bonds to carbon. Now, it's called a group, but the carbonyl group is not a functional group. Again, the carbonyl group, even though it's called a group, is not a true functional group, but it's found in many key functional groups we'll talk about. I mean, really many. And therefore, in my opinion, it's one of the most important things of organic chemistry, which is why you should know how to describe with words and a drawing what is the carbonyl group. Carbonyl group, carbon double bond to oxygen. Now, if we look at a ketone and aldehyde, hold on, which I have here, both have a carbonyl group, carbon double bonded to oxygen. Aldehyde, carbon double bond to oxygen, it's also got the R and H on that carbonyl group carbon. And ketone has 2 R groups, R and R prime, on the carbon that's part of the carbonyl group, carbon double bond to oxygen. Now, something very personal. If someone asked me, Dr. White, what kind of chemist are you? What kind of organic chemist are you? And if I was being honest, which I try to be, there's only one answer I would give. I am a carbonyl synthetic organic chemist. Again, I'm proud to say that. I am a carbonyl synthetic organic chemist. Most of my training and a lot of the work I've done, both in academics and in industry, have dealt with the carbonyl group and what I can do that nobody else could. Dr. White loves carbonyl groups because I'm a carbonyl synthetic organic chemist. Now you know what that means. Remember, synthesis means to make. All right, let's continue on. Let's talk about the nomenclature of aldehydes and ketones. And how do you do an aldehyde? Well, I've got the rule here, but let's write an aldehyde on the whiteboard to go through it. Now, one personal note, when I learned organic chemistry at IIT, the instructor I had, who was pretty good, always wrote is oxygen containing functional group starting on the right. You could have started at this end and rewrote it where you flipped it. Guess what? Good habits I don't change, and I'll write it on the front, on the right. You could also put it on this side, but I won't. But if you want to on a test, that's okay. All right, the question is, give the IUPAC name for, and let's call this A. And how do you do that? Well, you look at the molecule and look for what's different. What's not carbon, what's not hydrogen should get your attention like that. Oh, that didn't do good. Like this. That got your attention, I bet. And, ooh, I've got an oxygen. And it's double bond to carbon, carbonyl with the hydrogen carbons. And that's an aldehyde. How do you name an aldehyde? All right, before we go, there's something terminology I'll never ask you on a test, but you need to know because I'm going to use it in class. The carbon double bond to oxygen in a carbonyl group, ketones, aldehydes, and you'll learn other things. It's called let me make this larger. The carbonyl carbon. And Dr. White loves carbonyl carbons. They've been good to me and I've been good to them. So what do? How do you name this compound A? You find the longest chain with the carbonyl carbon in it. This one right here. 1, 2, 3, 4, 5. You've learned the table, the alkane's name. 5 is pentane. For an aldehyde, which this is, you take the ANE ending, drop the E, and change that to ANAL. So I drop the E, put AL, pentanal. Now, the carbonyl carbon, because it rocks, it's the best, and it is always carbon number 1 in an aldehyde, always. And everybody knows that. So you don't have to put the number 1 here because it's impossible to have an aldehyde with the carbonyl on carbon 2. That's called a ketone. I'll show you in a little while. And I'm done. Now, alkyl groups, since you know this is carbon number 1, you know how to number and name those. So let's do one. And the question would be, and now I'm going to let you have some fun too, name the following compound. And here, what do? You look for what's different. Ooh, what's not carbon, what's not hydrogen? Ooh, an oxygen. And it's double bond to this carbon with the hydrogen carbons on it. What do we call that? An aldehyde. And how do we name aldehydes? Find the longest chain with the carbonyl carbon. That's this one right here. 1, 2, 3, 4. 1, 2, 3, 4. Either way, you have 4. And 4-carbon alkane is butane. But for aldehydes, you drop the E at the end of butane or the alkane name, and you replace it with an Al. So that would be butanal. That's an Al. But as soon as we say that, that's spoken for. Are we done? No. Look what's here. It's your good buddy, the methyl group. And now you have to figure out what carbon is that on. Carbonyl carbon is always 1. And therefore, it's 3-methyl butanal. Now, remember, alcohols have an OL ending. Aldehydes have a AL ending. So, quick warning, for test number 2, make sure when you're writing your answers, make sure your OL looks like an OL and your AL looks like an AL. You don't want me guessing when I'm grading, because I have a 50% wrong at guessing wrong. I don't try to, but if I can't make it out, what is it? I have to guess. Don't want me doing that. I don't want me doing that. So make sure for aldehydes, you make sure that AL looks like an AL. Oh, I see a question. Jordan just asked a good question, which I violate all the time. And the question is, if you put a capital letters anywhere in the name, will I mark it wrong? And the answer is no. If we go back to the example, but that's not it. That's it. Wait, hold on. Zoom is being zoomy to me. All right, everybody see my whiteboard? Anybody? Just give me a thumbs up if you can. Thank you, Jordan. All right, now if you look right here, I've got a capital B. And guess what? Capital P there. It's a bad habit of mine. When you're keyboarding, which you really don't do on my test, some people will type in, then it should be all lowercase. That's the IUPAC rules. They have rules for that. But I'm not going to hold you to them. Don't tell anybody I'm being nice. Ruin my image around here. All right, let's go back and look at the rules I had on a sheet, which I just went down. Find the longest carbon chain. When they say includes the aldehyde, we're talking about the carbonyl carbon. Name that chain as per the IUPAC rules for alkanes. Drop the E at the end of ANE and replace it with AL. And this is important. Note, the carbonyl carbon is always number 1 in aldehyde. So you don't have to put that number down. And then name and number all the other substituents, just like you've learned already. So let's have some fun. Oh, wrong chapter. Right chapter. And the question is, give the IUPAC name for that compound, and it's your turn. And it's time for you to vote if you finish. All right, I think everybody's done. So it's my turn. Now, how do you name this compound? Remember, the question is give the IUPAC name for various molecules. And you look at the molecule and look for what's different. What's not carbon, what's not hydrogen. Ooh, an oxygen. And it's double bonded to carbon, has a hydrogen on it, and an R group. And what do we call this? An aldehyde. And how do you name an aldehyde? You find how many carbons are in the chain, including the carbonyl carbon, the carbon double bond to oxygen. And you name that as an alkane. Well, I go 1, 2, 3, 4, 5. Or I go 1, 2, 3, 4, 5, 6, 7. I hope you all agree 7 is greater than 5, and 7 alkane is heptane. But for an aldehyde, you take the A and E ending, drop the E, and add Al, heptanal. Carbonyl carbon is always 1. Therefore, this is 2, this is 3. What do we call this group here? 3 carbons, and the center carbon is bonded to, in this case, the chain, an isopropyl group. And what carbon is it on? Carbon number 3. So this is 3-isopropyl heptanal. Oh, let's do another one. These are fun. And say hello to a very dear old friend of mine. And what is the IUPAC name for that molecule? And then I'll tell you why it's a dear old friend, and it is. Excuse me, the temperature out there is zapping all my energy. And don't forget to vote if you're done. If you had your webcams on, I could see if you're done or not. Hint. All right, let's do this. How do you name this compound right here? Well, first of all, you have to figure out what functional group are you dealing with, which is another way of saying, look for what's different, what's not carbon, what's not hydrogen. Ooh, oxygen. And it's double bond to carbon with the hydrogen carbons. It's an aldehyde. And how do you name an aldehyde? Find the longest chain with the carbonyl carbon, carbon double bond to oxygen, name that as an alkane. Drop the E and replace it with Al. So how many carbons longest chain? I better start counting. One, and it's got to have the carbonyl carbon, carbon double bond to oxygen in it. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. I hope you all agree 6 is greater than 4. So 6 carbons, hexane. Drop the E, add Al, hexanal. And as soon as I say hexanal, first of all, that's all spoken for. And don't forget the carbonyl carbon, carbon double bond to oxygen is always number 1. Therefore, what's this? Oh, it's an ethyl group. And if that's 1, this is 2-ethyl hexanal. Now the question is, why is that an old friend of mine? Well, I used the properties of 2-ethyl hexanal to do what nobody else ever was able to do. And that led to new products being formed at the company I was working for, Axo, and it led to my first US patent. Yay! Now you know why Dr. White loves aldehydes and ketones. Let's count. Maybe I miscounted. 1, 2, 3, 4, 5, 6. Now, what I think you're talking about is 1, 2, 3, 4, 5, 6, 7. It has to include the longest chain, this carbon. That's how you name aldehydes. It has to have the carbonyl carbon. It's not just the longest chain, it's the longest chain with the carbonyl carbon. That one. Oh, I'm getting pretty good with this tablet. Does that help? Thank you, Jimmy, for your question. All questions are good questions. As you can see, I practice what I preach. There's no such thing as a dumb question in my class or in my life. All right, now there's one special aldehyde that IUPAC in their infinite wisdom said, you know something, we're not going to get these organic chemists to call it something else because they've been calling it this name for eons. So let's make it the IUPAC name. And that molecule is this. When R is a benzene ring, what's different? Carbonyl, well, you got a benzene ring too, but this is an aldehyde. And now, how do you name it? Well, the common name that became the IUPAC name is benzaldehyde. And you need to know, if I put this on a test, what's the IUPAC name for that? And the answer is benzaldehyde. And from the lab you just did, you know that smells like cherries and also almonds, both at the same time. I can smell it and smell the cherries, and at the same time, I can smell the same thing and smell the almonds. My brain can do that. Most people can too. By the way, whenever I smell benzaldehyde, the first thing I think of is Dr. Pepper. And yes, I'm a Dr. Pepper person. Who do we have time? We've got time. Time to share something with you. And that is, if you like pop, and remember, I'm from the Chicagoland area all my life, except when I went to grad school in Michigan, at Michigan State in East Lansing. And even then they called it too. It wasn't sort of just over there. I think we're at the same longitude. Is that the right term? I don't know. But anyways, Dr. White loves Vernors. And everybody see on your screen right now, that's Vernors. I have a couple of 12 can cases in my house. And this is a very, very highly carbonated, strong ginger ale. And once you drink Vernors, you're not going to go back to the other stuff. It's that good. But that's my personal opinion. About the easiest place to find Vernors in Chicagoland area, go to any local Jewel. They sell it. I don't get any money back from Vernors or Jewel. I've got to find a way to do that where I show product in my class and they give me money. Nah. All right, now let's move on to ketones. Now, ketones, here's the rules, but let me show you a ketone. If we look at this molecule, and there's another way I could also draw it, which sometimes I will. This helps when we're doing certain reactions. I'm sort of showing the bond angle here, sort of. And organic chemist right either way. What is the IUPAC name for this 3 points? And what do? You look for what's different, what's not carbon, what's not hydrogen. Ooh, oxygen. Is double bond to carbon. Got carbons here, I'll call R prime. I got carbons here, I'll call R. And you can switch it, doesn't matter what you call R and R prime. And the one below is the same thing, same molecule. Now, how do you name it? You find the longest chain with the carbonyl carbon. Then this molecule is 1, 2, 3, 4, 5. And what's 5 carbons? First of all, this is a ketone. And 5 carbons is pentane. Now, ketone, similar but a little different. And the way it's different is take the longest chain, and also you can have ketones in a ring. We'll talk about that. And drop the E at the end of the name, pentane. and that gets replaced with ONE. Now for acyclic, you need a number. Which carbon is the carbonyl carbon? Carbon double bond to oxygen. For cyclic, and unlike aldehydes, which you cannot have in a ring, ketones you can. And for cyclic, we'll do that today. You don't need a number because the carbonyl carbon in a ring is always number one. It rocks. So how do we do this? We come up here, this is a ketone. Drop the E, add ONE, pentanone. What carbon is the carbonyl carbon? Well, always gets the lowest number. Remember, for acyclic, you always start counting at either end of the chain. If I start this way, 1, 2. If I start this way, 1, 2, 3, 4. Which is smaller, 2 or 4? And hopefully all said 2. So this is 2-pentanone. How do we do that? We find the longest chain with the carbonyl carbon, carbon double bond to oxygen. 1, 2, 3, 4, 5 carbons. Name it as a alkane pentane. Drop the E, add ONE, pentanone, and then you need a number. In a ring, that would always be 1. So first of all, let's try the following. And what would be the name of that molecule? Even though I've got it bent, you can start counting 1, 2, 3, and so on. Your turn. For those of you who came in late, which a couple of you did, you missed something cute. I'll do it again right now while others are working on the IUPAC name for that compound. My best friend's wife, who I'm also very close with. In fact, I've been best friends with him since about, 1965. He's that good. And we got married about 1978. I met his bride-to-be. And unlike people I know, and it's happened to me, we can be friends with one person of a couple and not get along with the other. His wife, since then, we've also been very close. We're like family. He's like brother I never had. And she's like the sister, which I do have. Anyways, she sent me this and I thought I'd show it to you. Everybody see that? By the way, I don't smoke anymore. They haven't been for decades. All right. And don't forget to vote. Speaking about that, the primary is coming up in Illinois, and you can get an absentee ballot. You can now early vote, or you can vote on election day. Remember, brave men and women have died so you can vote. Make sure you do, please. I've only missed one election all my life, and that was a minor, just a local primary, not a state and federal primary. And the reason I missed it is I forgot to get an absentee ballot because I was in Germany. And that's the only time. After that, I made sure. All right. Let's do this. All right. How do you name this? You look for what's different. Ooh, oxygen, double bond. Ooh, I made a mistake. Somebody should have caught me. There shouldn't be a hydrogen there. And you have an oxygen double bond to carbon. Carbon's here, carbon's here. And what do we have? A ketone. And ketone is not spelled with a Y. And how many carbons are in the longest chain with the carbonyl carbon? 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. Either way, 6. 6 is hexane. Drop the E. And replace it with ONE. Strange, I never say replace it with 1. I always say ONE. Next, since it's acyclic, you need a number. I start from this side, 1, 2, carbonyl carbon is 3. If I start from this side, it's 1, 2, 3, 4. Carbonyl carbon always has priority, the lowest number. So this is 3-hexanone. Are we done? No, we've got an ethyl group. This is 3, that's 4. So it's 4-ethyl 3-hexanone. Oh, I like aldehydes and ketones. And that's how you do it. Speaking about doing it, it's time for our first break. Don't forget later today, we'll do our lab. It's a good one. And I'll see you at 2:55. time to get going. All right, let's get back to work. We're talking about ketones and aldehydes and the IUPAC name for those. And if we look at, for a ketone, which I just found, find the longest carbon chain, which includes the ketone, which means the carbonyl carbon double bond to oxygen. Name that chain as per IUPAC rules for alkane, and I'm going to go through this in a second for cycloalkane. Now, you drop the E at the end of the ANE and replace with ONE. Now, the carbonyl carbon is given a number in front of the main alkane name, or now ketone or aldehyde name, and the priority, and it has priority lowest number in the chain. Now, what I didn't write here is for cycloalkanes, which I'm going to go through right now. Name and number all other substituents for the IUPAC rules for substituents, which we did. Now I'm going to have some fun. I am having fun. Dr. White loves cyclic ketones. Now, watch closely. What's the IUPAC name for this compound? Well, the first thing you have to realize is what functional group. And you look on what's different. Oxygen double bond to carbon here. Now, if we look at this ring, I have carbons here and here. And think of it this way. Carbonyl, carbon double bond to oxygen, carbons here. They could be the same or different, but in a ring, R and R prime are bonded together. And therefore, how do we do a ring? Finding, just like a cycloalkane, find the number of carbons in the ring. 1, 2, 3, 4, 5, 6. Every bend in the line is a carbon. 6 carbons is hexane, but it's a ring. Don't forget, cyclohexane. But it's a ketone. ANE ending, in this case, cyclohexane, drop the E and replace that with ONE. Cyclohexanone. The carbonyl carbon in a ring is always number 1. It rocks. It's the best. Biased, you better believe I am. And therefore, you don't need a number. I'm done. But if you have alkyl substituents, this is always 1. And you number the other alkyl groups on the ring in such a way they have the lowest numbers. That's your turn right here. Give the IUPAC name for that molecule. Oh, am I so excited. We're talking about one of my favorite areas of all of organic chemistry. Yes. And don't forget, my heart of hearts, I'm a Carbonyl synthetic organic chemist, and I am. If you're done, don't forget to vote. Say yes. All right, let's get moving. So, question is, what's the IUPAC name for this molecule? Well, you look for what's different, what's not carbon, what's not hydrogen. Ooh, oxygen double bond to carbon in a ring. This is a ketone. And just so happens in the ring, R prime and R double prime are bond together. And this is a ketone, cyclic ketone. And you find the name of the cycloalkane, name it as a cycloalkane, the ring that has the carbonyl carbon in it, drop the E for a ketone, O-N-E, add O-N-E. So how many carbons in this ring? 1, 2, 3, 4, 5. Cyclo, remember we need that for a ring. Pentane. I'll drop the E, which I did, put O-N-E, cyclopentanone. By IUPAC rules, the carbonyl carbon is 1. And you go clockwise or counterclockwise. So the other, all the substituents, the alkyl groups, have the lowest number. And notice on carbon 3, we have an N-propyl. And I should have made it closer together here. Well, let me make it closer together. Look better and I'll feel better. And that would be 3N-propyl cyclopentanone. Now, if your Y or L and C were far apart, as long as they're on the same page, I don't care. But for you, I'm trying to make it look good. And then I do care. Oh, let's do another one. Who is this pretty? Now you know I'm an organic chemist. What would be the IUPAC name for that molecule? 3 points each. Don't forget to vote in the poll if you're done. If we're face to face, I could look around, I could tell when everybody's done. But nobody has their webcams on, so I can't do that. All right, I'm gonna assume everybody's done. My turn. Now, question is, what's the IUPAC name for this molecule? How do you go about doing that? You look for what's different. What's not a carbon-carbon single bond or a carbon or hydrogen atom? Ooh, oxygen, double bond to carbon, carbons here and here. That's a ketone. But it's a cyclic ketone. So how do we do that? You name the cycloalkane that the carbonyl carbon is in, the ring that the carbonyl carbon, carbonyl carbon, carbon, double bond to oxygen. And you name that as a cycloalkane, drop the E, add ONE. So how many carbons a ring? 1, 2, 3, 4, 5, 6. Cyclohexane. But it's a ketone. Drop the E, add ONE. Cyclohexanone. This carbonyl carbon is always 1, the ketone in a ring. Therefore, this is 2, 3, 4. And therefore, what's on 4? T-butyl group. What's on 2? Oh, it's your old friend, the methyl group. So we have, are you ready for this? Deep breath time. 4, T-butyl. 2, methyl. Cyclohexanone. Say that quickly 5 times. No, you don't have to. Let's go through it again. Find out what's different. What's not carbon, what's not hydrogen. Ooh, oxygen right here, double bond to carbon. And that's a ketone. Name the ring that it's in, cyclohexane, drop the E, add ONE, cyclohexanone. The carbonyl carbon of a ring is always number 1. And therefore, this is 2, 3, 4. And therefore, you don't need a number in a ring because the carbonyl carbon is always number 1. And here we have a methyl group and a T-butyl group. That's on 4. That's on 2. Now, don't tell anybody I'm being nice. You had put 2-methyl-4-tert-butyl cyclohexanone, I'd still give you full credit because I'm not holding the alphabetical rule, but I hold myself to it. And that's how you do one type of nomenclature. Now, there are 2 types of nomenclature skills organic chemists should have, and questions, nomenclature questions, I put on tests, like test 2 coming up. I think it's a week from this Thursday, or I'll have to look. But I could write something, I draw the molecule for the following name or whatever, and let's do one. And the question is, draw this molecule. Well, how do you do that? Start from the right, move left. Al ending. Aldehyde. If this were an E pentane, 5 carbons. Now, I'm going to put the carbonyl on the right. You could have easily put it on the left. Remember, there's 4 bonds to carbon. And now, this is always carbon 1. On carbon 2 is a methyl group. And I'm done. And now it's your turn. And by the way, that's Al. Hold on. See, I've got to be careful. There you go. Why don't you draw 3N-butyl decanal? Go. And don't forget, not today, but tomorrow, if you have any questions, stop by my office hour, 6 to 7 p.m. on Zoom. Again, not today, but tomorrow. Now things are getting really exciting. But then again, I warned you, I love aldehydes and ketones. Don't forget to vote in the poll. All right, let's get going. How do we know what to draw? How do we decode this secret name? And the answer is you start from the right, move left. Al ending, aldehyde. If this were an E instead of Al, decane, well, that's 10 carbons. And here we have our 10 carbons, but it's an aldehyde. So the end carbon, I'm going to do it on this end. You can do the other end too, but I like this end. Like I said, good habits I don't break. We have decanal. The carbonyl carbon double bond to oxygen is always 1. This is 2. This is 3. As we go this way on carbon 3, N-butyl, which means the end carbon of 4 carbons, N-butyl. And now I know there's 4 bonds to carbon, and I can put in the hydrogens. Wow, I got a lot to put in. A lot. Check with me tomorrow when I'm done. No. And that would be the wrong molecule. Oops. Let's do the right molecule. It's on carbon 3, my N-butyl group. And there we have that aldehyde. All right, let's move on to another one. And why don't you draw the structure for 3-methyl-2-octanone, O-N-E ending. Your turn. Ooh, I'm going to see if you can solo. And don't forget, later tonight, I'll have today's lecture on my YouTube channel, where, didn't you know, I'm a YouTube star? Not. I apologize. I should have not thrown you off the deep end on this one, but let's see how you do, and I'll do it. All right, let's get to work. Now, how do you decode this to know what to draw? You start from the right, move left. ONE ending, ketone. If this were an E instead of ONE, that'd be octane. Octane, 8 carbons. And where is the carbonyl? Carbon double bond oxygen, carbon number 2. And now, am I done? No. I have a methyl group on carbon 3. This is 1, this is 2, this is 3. I'll put my methyl group. Now I know there are 4 bonds to carbon, and let me get to work. Oops. And there's the answer right there. And that's 3-methyl 2-octanone, carbonyl, carbon 2, and carbonyl, carbon double bonds oxygen. And the methyl group on carbon 3, we have 8 carbons because octanone, drop the ONE, put in an E, tells you octane, 8 carbons. And I'll do this one first. Draw the following molecule. How do you do that? How do you decode it? You start from the right, move left. ONE ending tells you ketone. Whoop, don't want to do that yet. And the cyclo tells you it's in a ring. If this were an E instead of ONE, cyclohexane, 6-membered ring. And carbon 1, you can put on any one, but most of you are going to start there. I have a carbonyl, carbon double bond oxygen. This is 1, 2, 3, 4. I have an ethyl group. And there you go. 4-ethyl cyclohexanone. And let's have you try one. I can spell. Let's try this again. There we go. All right, your turn. Draw the structure for 3-isopropyl cyclopentanone. And be patient. I try and give everybody time to finish. Let's try something instead of the poll. When you're done, give me a thumbs up. Remember, when you're done, give me a thumbs up. Thank you, Jordan. Are the rest of you almost finished? All right, let's do this. How do you do this? How do you determine what to draw? You start from the right and move left. You see ONE, that's a ketone. And if that were an E, cyclopentane is a ring with 5 carbons. And it's a ketone. You have a carbonyl, most of you are going to put it up here, carbon double bond oxygen. That's always carbon 1. This will be 2. I have an isopropyl group. and that's 2-isopropyl cyclopentanone. And that's how you do the IUPAC names for ketones and aldehydes. Now, normally we stop at 1:45, but I'm going to go a little longer. You'll still get your break. I'm not going to cheat you out of that. Let's continue on. There's a reason I'm doing this. Now, in aldehydes and ketones, there are a number of other ways of naming things, but I'd like you to know these two common names. The simplest aldehyde is formaldehyde. Nobody ever calls this methanal. And that has this structure, 1 carbon. And turns out R can be a hydrogen also. And you can also draw it this way. And those are other ways of drawing it. Or you could even draw it, which I never do, but I like that. These are all formaldehyde. I'm going to talk about formaldehyde in a second, something very important. Now, this common name, acetone, is a ketone. Nobody ever calls it 2-propanone, acetone. Now, for common names, I will not ask you, here's the structure, draw, give the common name, but I will ask you, here's the common name, draw the structure. Now, acetone is one of the 2 nail polish removers. And if you go to a big box store like Target or Walmart, I don't think they have supply chain problems with this. You can find some nail polish remover that's essentially acetone with a little perfume in there. So it smells nice. Now, it turns out another molecule used to be acetone was on its way down by how many bottles you saw on the shelf. But the super tough nail polish that you put under the UV light, the other molecule that for many years was the most popular, couldn't do a good job removing that, where acetone did, and they've gone back. Notice I forgot to polish my nails. Sorry. But anyways, no, I don't polish my nails. This is acetone, and you should know acetone is used as nail polish remover. In fact, now if you go, because of the super durable nail polish, you'll find the majority of bottles in the area where they have the nail polish remover are acetone based. All right, like I said, I'm going to go a little over. Hang in there. This is important for you. I'm going to talk about something, the switch. Will this be on test? Click no. Should you know about it? Yes. And I won't cut it out. Now, a number of years ago, I don't know if you're old enough to remember, we had a monster hurricane in the New Orleans, Louisiana, and that whole area of by the Gulf of Mexico. It did tremendous damage. And the name of that hurricane was Hurricane Katrina. And it did a tremendous amount of damage. This was August 2000. Wow, that's a long time ago now, but it just seemed like yesterday, unfortunately, in my mind. And what happened was Hurricane Katrina destroyed a lot of people's homes. At that time, we had President George Bush, the second one, who was not the best president. I could use stronger words, but I won't. And he had unfortunately put this totally inept person who had no experience in charge of FEMA. That's the federal agency for taking care of disasters. And they botched everything. Well, to try and help people who are homeless, the government spent a lot of money with trailer companies, mainly located in Indiana, to build trailers, hundreds of thousands of them. And these were known as Katrina trailers from the hurricane. Well, around that happening, a couple months after they had been used, I had heard about something that got my radar up, my little radar antenna, and that was that people were getting sick, very sick, living in these Katrina trailers. And it turns out there was this very brave woman, and she's still alive. At least I haven't checked with her in a while. I hope so. Becky Gillette, who found out what was making these people sick. And it was formaldehyde coming from the wood of the trailers. But President Bush and the head of FEMA, and they tried to get the EPA to join in, saying Becky's wrong. But she was using a good testing lab, and they couldn't prove her wrong. And when I heard about what she was doing in the news, being socially responsible, that's what my parents raised me, and being an organic chemist who's also a world authority in formaldehyde. I worked for the company that was the largest producer of formaldehyde in the United States. I know the dangers, and I also know properly used formaldehyde is safe. And so I was able to track down her phone number, and I called her. And I said, I hear what you're doing, and I'd like to support you in any way I can, and I won't charge you a penny because I'm a consultant, and I could have. And Becky was a member, I don't know if she still is, of the, I got a mental block. What's the environmental group? Sierra Club. And so she said, I could use your help. And one of the things she asked me to do, because of my credentials as an authority, was then, luckily, we had new President Obama, write to him and also write to the head of the EPA. And I wasn't the only one she asked, and I wasn't the only scientist doing this, to change the regulations for amount of formaldehyde coming from wood. Now, what you don't know, but I do, because I work for a company that made these products, use formaldehyde to make a resin. And a resin is a fancy name for glue. And if you do it correctly, all the reactants react together, but you got to know how to do that. And it costs extra money to keep the what's called free formaldehyde level down. The other thing, which is in the United States, but not in places like China, is we have OSHA, which is the Occupation Safety Act authorization or something like that. And that governs safety in the workplace. And OSHA has rules for what exposure, how much over an 8-hour period you can have with products with formaldehyde. So that keeps the formaldehyde level in those products low, and products that are made from those products. Now, are you familiar with plywood and particle board? Those are either sheets of wood or pieces of wood glued together with a phenolic resin that uses formaldehyde. And if you don't, it's cheaper not to keep the free formaldehyde low, but with government regulations for when we sell to a company who wants to use, or I work for it, the resin, it can't be above that limit OSHA. Well, if you're in China, you don't have that. Now, here's what happened. Because of the hurricane, there was a tremendous shortage from people boarding up their windows and then trying to rebuild a plywood and particle board, and also another similar product, oriented strand board. And because of that, most likely, I can't prove it for a fact, but I'll bet on it, I'm sure it was right, the companies that were making trailers went to China to get wood, plywood. And they made these trailers with plywood that were very high because they don't have an ocean over there keeping the level of formaldehyde low in the wood. And that came out of the wood. People were breathing it and getting very sick. Pets were dying. Young children were getting very sick. Older adults were getting very sick. I'm not sure if anybody died, but they came close. They were very sick. And because of what I helped with Becky, President Obama put in place regulations with the EPA that lowered that. You still got to be careful. Now, what I want to show you is the following. Everybody see on your screen toxic trailers? Thank you. All right, now this is Becky's slide. I don't think she keeps it up anymore, and I'll explain why. There's a picture of Becky right there. If you scroll down, you see where it says test for formaldehyde. This is the company Becky used, and she used her own money out of her pocket to help these people, which was amazing. I hope someday she gets a medal or some recognition from our government. But anyways, this company, and I've had students who've used it, if you buy new furniture that's not solid wood, like for a baby's room, or you have new kitchen put in that's not solid wood, I would buy one of these kits. And what you get is a disc. You take it out of the packet, you leave it in a room for 24 hours, you put it in a mailer, send it to this company, they'll analyze it, and they'll either send it by US mail or email. What is the level of formaldehyde? Is it toxic or not? And they're accurate. The EPA tried to prove them wrong and didn't. Just prove they were doing a really good job. It costs $39 for a kit or for a room, and for your health, it's worth every penny. When working with Becky, she had me talk to a woman who tested homes for formaldehyde in California. And that woman told me a very sad story. This one very young, not that young, but young couple who were doing quite well. He was a National Hockey League player, and she was a stewardess. And in their home in California, this woman lived in California, they spent about $50,000 on a new kitchen. All the wood came from China. The cabinets were made there. They didn't know that. And all of a sudden, when they came home, they were getting sick, these very healthy people. Now, when he was on the road playing hockey, or she was out flying, doing her job as a stewardess, they weren't sick. And what this lady who tests for formaldehyde found that the wood was just like the trailers, giving off a lot of free formaldehyde. So it's something to be careful for, and listen carefully. If you ever have a question about this in formaldehyde, any wood, always feel free to contact me. Now, quick thing. Becky also asked me, Congressman Waxman and Select Committee was going to have a hearing it was going to be televised live on TV with the owners of these trailers that people were getting sick in. And Becky asked me, would you be willing to talk to the lead investigator for Congressman Waxman's committee? I said, sure. And he called me up, I can't remember his name. And we talked for about an hour, and I was educating him about formaldehyde and all that. And afterward, he thanked me, and I said, could you do a favor for me? He said, what? I said, could you ask at the meeting, I think it was 2 days from when I was talking to him, could you ask Congressman Waxman to ask the owners of the trailer companies who made these trailers that people were getting sick one question? So what's the question? Ask them where they got their wood. And he said, immediately, I can't. And I realized that whole thing was just a uh, show to indicate to people, ooh, we're getting serious. And they weren't. Sad but true. With that, ooh, I went over. Come back at 3:57. Let's take our 5-minute break and we'll do our lab. But that was important for me to teach you. I'll see you in 5. Be with you in a minute, maybe less. All right, sorry about that. Have to get everything ready. And it's lab time. I should get you back. Time to get going. It's lab time. And today's lab deals with aromatic electrophilic substitution. And if we were in the lab, I'd be warning you right now, we're going to be working with concentrated sulfuric and concentrated nitric acid. They're very dangerous. Be careful. Dangerous chemicals should never be feared, but handled properly and carefully. That's why they're dangerous, and you make sure. Now, when we do this lab face-to-face, which we're not, it's an added safety, because normally I don't ask students to wear lab coats or anything like that. But this lab, I require students either to wear a long sleeve top or a lab coat. And I tell students, do not, and make them wear rubber gloves, which I provide, or the school provides. And don't touch your face or your arms when you're wearing gloves on, because you can get that acid on your face or anything. And unfortunately, that happened once. Luckily, I knew what to do. Now, today's lab deals with the reaction of electrophile. And we already talked about this for test number 1, but I thought I'd put this. Now, if we look at the reaction we're going to look at today, let me put it on the board. And you learn for test 1, you take a benzene reacted with nitric acid and sulfuric acid, you put a nitro group on a benzene ring. Nitrobenzene in this case. Now, pay attention. And think of the sulfuric acid as H+. Let me write the nitric acid slightly different. And when these react together, what you get is this cation. And did anybody see something in here that looks familiar? Two hydrogens, one oxygen. One oxygen, two hydrogen. Two hydrogens, H2, oxygen O. Water. And whenever in a molecule, you can form a good leaving group, a stable molecule, and water is one of the most stable, if not the most. You lose water. That's what this means. And what are you left with? This, the nitronium ion. And this is what attacks the benzene ring. It's got a plus charge here. It's looking for electrons. And benzene has 3 double bonds bond together. And remember that ring in an aromatic ring. And it's a lot of electrons. And this is saying, woo, I'm going to go attack you. And it does. And that's why it puts on a nitro group. Again, the sulfuric acid, the nitric acid forms this, which you lose water. And the key, why do you react nitric and sulfuric acid together? Because this is what you form. Now, what happens, and I have this in the lab, the write-up, but I'll do it here on the board. It's easier for you to see. What happens if you have something on there? And you have an electrophile, where will it go? Well, it turns out it could go here and here, and that's the ortho position. It could go here or here, and that would be the meta. Remember, 1, 2 ortho, 1, 3 meta, or it could go here, para. Now, if you ever gone to a swap meet or county fair or something, or a big concert where they take this open field or big open space and make it into a parking lot, and what do? They have those people who don't like me, and I don't like them that much. I don't like them, but I just don't listen to them. And they say, people will come in, they'll park this way, we're going to fill this row. No, we don't want you parking close here. Fill this row first. And they're directing you where to go and park. I don't listen to them, so they get mad at me. But anyways, I've been to a concert or a place like that in a long time. But anyways, when I did go, they get mad at me. And those people are directing you where to go. Well, it turns out the Z group on a benzene ring, if there's a substituted benzene ring and you're reacting it, putting an E group on somewhere, the electrophile like NO2, the Z group is a director. Or sometimes called a director group. And depending what Z is, there are 2 types of directors. One type is an ortho para director. And therefore, up here, the incoming group will either go to the ortho position or the para. It can go both or one or the other. The other type of group is a meta director. That's what Z is. And I won't get into it, but if Z is electron withdrawing or electron releasing, it determines what type it is. Now, listen carefully. Sometimes Z can be large. And if we look up here, if Z is really big, it blocks off the ortho position, so you only just get para. If Z is large, you may only get para isomer. If that happens, it's still called an ortho para director. Even though you're only getting para, you get any of these 2, it's always called an ortho para director. If you get meta, it's called a meta director. Now, in this lab, you've got to find out bromine on a ring, is that an ortho para director or a meta director? And the reaction you're going to do, if we're face to face, you start with bromobenzene and you react it with nitric. It's a dangerous but exciting reaction, and sulfuric acid. And what you get, and this is not the actual product, so I'm not going to give away the answer, is somewhere on this ring, and this is the way of not giving out the answer. See, it's even written on the screen. You put a nitro group. Now, does it go ortho, meta, para, or ortho, para? Well, that's where you find out. How do you find out? Well, let's take a look at the lab. Now, I already talked about types of ortho, para, and meta. You can go back. And if Z is very big, you'll just only get para. But it's still called an ortho para director. So there are only two names you can call directors, ortho para or meta. Now, in this lab, you're going to be reacting nitric and sulfuric acid. Why do you do that? I just showed you the form NO2 plus, and that's going to put a nitro group somewhere in the benzene. I drew it this way because I'm not going to give it away. Now, in this lab, here's some YouTubes I'll let you watch. It's really neat. You should watch them. And we start out, heat some water. We put boiling chips in there so the water doesn't, guess what? Bounce or burp or bump. That's the right word I was searching for. Now, you'll have a round bottom flask, and you'll first put in sulfuric acid, 3 milliliters. Next, with cooling, you'll very carefully add as little at a time the nitric acid. And what you're doing by doing that is forming the nitronium ion. Next, while it's still cold, you'll add 1.6 milliliters of the bromobenzene. You'll swirl it for a minute, take it out of the ice bath, let it come to room temperature or warm up a little, and then you put it into boiling water for 25 minutes. Now, an interesting thing I haven't talked about all semester is the fact that when you run reactions, sometimes there are impurities in things you use. And you can have what's called side reactions. You make things you really didn't want to make. And for this reaction, it's pretty much a given that there's some impurity in the nitric or sulfuric that they react together under those conditions and form some nitrogen dioxide, which is a brown gas, a reddish brown. And I warn students about this. You're in a hood, you have the window down in a hood, and that gets all the vapors away, anything dangerous, and shoots it out in the roof of the building, and the air currents dilute it so it's safe, and you're up, I don't know, 30 feet above the sidewalk level. And what you'll do is heat it. Then after 25 minutes, you take it out, let it cool. Now, because we only have an hour and 50 minutes more face-to-face, you don't have time to do the melting point. At the other school, we do have time, and we isolate it and do the melting point. But what I do is I ask you to show me your product, and these are my initials. I don't know if you've seen it before. Yeah, on the test key, a W with a K inside. And took me my whole freshman year, first semester, not whole year, of non-Western civilization class, history class. I was bored out of my mind. This teacher hated me because he knew I wasn't paying attention, but he couldn't do anything because I got the highest score. I was actually listening, just watching him. And if once you show me, I'll tell you in real life, the melting point of that solid is this. And here are the 3 possible choices based on this melting point. Either ortho-bromonitrobenzene, meta-bromonitrobenzene, or para-bromonitrobenzene. And when you melt things, if you're a rookie, which you guys would be if we were face-to-face, your melting point is always a little lower than what's called the literature value. Now, based on that, listen carefully. You have to put the name of your product in this line based on the melting point. Now, I'm not going to tell you. You got to figure that out. And then we have some questions for you to answer. And that's today's lab. Remember, we're trying to find out is bromine. This Z group is an orthopara or a meta-director. If you only get para when sometimes the Z is big, you won't see the ortho. But it's still called an orthopara director. I'll say that again, slow motion. Sometimes Z is big and it blocks the ortho position. So even though it's an ortho para director, you'll only see the para product, but even then it's still called an ortho para director. And you're going to find out based on the data, is bromine an ortho para director or meta? And I show it this way, and this is not the right way to draw the product, but it's my sneaky way not to give it away. And with that, I'm done for today. It's time for Dr. White to say, Gang gesund, goodbye. I'll see you tomorrow. Same bad time, same bad channel. Ooh, I did a generation gap thing on you. I'll see you tomorrow. Don't forget the hand in the lab that's due today. And with that, I'll say once again, Gang gesund. We're in a good place, so things are going good. Gang gesund, goodbye.